Lab 2, Magnetic Field of a Bar Magnet by Alan Zhu. The purpose of this lab is to compare the magnitude of magnetic fields in relation to the distance from the bar magnet and the observation location. The system was the magnetometer on the phone, and the surrounding was the magnets and the Earth's magnetic force. This experiment took place on my phone magnetometer. This was the app I used, and this was the bar I used. After calibrating my magnetometer, these are the results I recorded according to the PDF steps I took. On the right-hand side is a natural log bx versus natural log r. According to the PDF, the intercept is natural log k and n is equal to the slope. So in this particular case, natural log k is minus 11.05 and n is equal to minus zero point 0.5 approximately. Highlighted below is my off-axis field calculations. As you can see, the average is approximately 8.7 e minus zero point 0.5. Dipole moment calculation. As previously stated, natural log k is equal to negative 11.05. To derive k, we set e to the power of negative 11.05 to get k. To find the dipole moment calculations, we set the formula for b dipole in the parallel direction equal to k. We also remove r to the power of 3 in this calculation because k does not involve distance. Once we use simple algebra to isolate mu, we get approximately 79.44. In the experiment, we were given four statements that we were to confirm were true or false depending on our observations. In my observations, only 1 and 4 the statements were true. 1. When the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. This was true in my observation because we calibrated our magnetometer in accordance with the north magnetic field of Earth. 4. As the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. The x component of the magnetic field increases because the force of the magnet is inversely proportional to the distance between the observation location and the magnet. Here's my code. Highlighted is the 79.44 MU that I calculated previously from my magnetic dipole moment. Highlighted is my dipole B function in accordance to the PDF formula. Highlighted is the changed vector distance observation locations that I implemented. Highlighted is the B field calculations for each of the following observation locations previously stated. Highlighted is the visualization of the magnetic field 45 directions off axis in accordance to my experiment. D perp was equal to 0.025 to represent 0.025 centimeters, as determined in my experiment. Highlighted is an additional print statement that I added to calculate the magnitude of B field at a 45-degree angle. When you run the code segment, this is what it looks like. Net B at 45-degree distance of D was equal to 0.284213, which was much larger than my real-life experiment value. What if? What if the setup was not compensated for the magnetic north force of Earth? If not, we would have inaccurate magnetic force calculations on observation location due to magnetic bar. This is due to the inclusion of west and south magnetic forces acting on the magnetometer, blurring the value of the magnetic force of the actual magnetic bar. What if? What if two identical magnets were stuck together? If two identical magnets were stuck together, it would create a stronger magnetic force as we are doubling the magnetic dipole moment with the inclusion of two identical magnets stuck end to end. This would be dramatically stronger than one singular magnet.